In this video, the learner will use the distance formula to calculate the length of a segment in 2 dimensions. We're going to first derive the distance formula using this segment here, which has a length of c. Now, what we're going to do first is we're going to draw a horizontal and vertical distance and create a right triangle. We know from using Pythagorean theorem that we can solve for the length of c using c squared equals a squared plus b squared. A and b represent the length of the legs of the right triangle. A is that horizontal distance here, b is the vertical distance. I can actually find those horizontal and vertical distances using the coordinates. So the horizontal distance, I can use my x values of the 2 points that I have, and the vertical distance is going to be the difference in the y values along that segment. Notice if I were to solve for the value of c in this equation, all I have to do is take the square root of both sides. When I do that, I have the square root of x2 minus x1 squared plus y2 minus y1 squared. This is actually my distance formula, being derived from Pythagorean theorem. I can actually use this formula with the points that I was given. x1, y1 can be the first point, x2, y2 can be the second point, and I can plug those values in. So I have negative 2 minus 3 squared plus 4 minus a negative 6 squared, and all of that is being square rooted to be able to find the length of c. From here you just have to follow order of operations. So I'll have negative 2 minus 3, which gives me a negative 5, 4 minus negative 6, which gives me 10. Negative 5 squared is a positive 25, 10 squared is 100. Add those together and you get 125. When you square root that and simplify, you get 5 root 5 as your exact answer. 5 root 5 is the length of that segment. So we have the distance formula that we derived from Pythagorean theorem for any 2 points on the coordinate plane, x1, y1, and x2, y2. We can use the distance formula of the square root of x2 minus x1 squared plus y2 minus y1 squared. We want to find the length of the segment between the points negative 3, 7 and 4, negative 5. We're going to use that distance formula. So first, go ahead and label your points x1, y1, x2, y2. It just helps keep things straight so you know exactly what goes where in the formula. So x2 minus x1, that's going to be 4 minus negative 3. y2 minus y1 is going to be negative 5 minus 7. From here, just follow order of operations. Do parentheses first to get 7 squared plus negative 12 squared, all under the square root. 7 squared is 49, negative 12 squared is a positive 144, and add 49 plus 144, and we have the square root of 193. 193 cannot be simplified underneath the radical, and so that is my final answer. I do want you to answer this question in your notes. Would it matter if we switched the labels of the points? Would we get a different distance if we let negative 3, 7 be x2, y2, and 4, negative 5 be x1, y1? These questions I want you to do on your own using the plotted points A through F on the grid. What is the length of the following segments? You're going to find each one of those measures. Answer the question, are segment DE and segment CE congruent, and how do you know? And then number 3, point C is between F and G. G is not on here yet. You guys are going to have to figure out what the coordinate of point G would be and be able to plot it on the grid.